number 43 upon 2 raised to the power 4 into 5 raised to the power 3 will terminate after how many places of decimal?
Ma'am?
Yes.
Ma'am, your voice is a bit low. Ma'am, could you speak a bit loudly? I don't know what exactly you do.
Okay. Now is it audible?
Yes, ma'am. Now it's okay.
Okay. So try this question and let me know the answer, okay?
So, ma'am, are we supposed to send you the answer on personal chat or just?
Yes, you can write the answer on chat.
Okay, ma'am.
Okay. Yes, Somili, your answer is correct. Yes, Arushi. Great, great. Yes, 4 is the correct answer. So why 4 is the answer? Let's discuss the solution now. So this is a rational number, right? It is 43 upon 2 raised to the power 4 into 5 raised to the power 3. It is given. And we have to find that after how many places of decimal it will terminate. So whenever in the question it is asked to tell how many places of decimal it will terminate after, what we do is we form the pairs of 2 and 5 in the denominator. And the thing is that only 2 and 5 are present in the denominator. That is why it is terminating. This we all know, right? So let's form the pairs of 2 and 5. So there are 4 2's, but only 5 3's. So what we'll do is, if I multiply 5 in the numerator and 5 in the denominator, then what do we get? Is 215 upon 2 raised to the power 4 into 5 raised to the power 4. So what we get is 215 upon 2 into 5 is 10, 10 raised to the power 4. So we know that as in denominator, the power of 10 is 4. That is why it will terminate after 4 decimal places. As in the denominator,
Ma'am, writing the statement would be necessary.
yes, to fetch marks, it is important. It is very important to write the steps so that not even half marks is deductible anywhere. Okay. Four.
So, ma'am, we always have to bring the denominator in the form of 10.
Yes. You have to bring the denominator in the form of 10. That is why we are multiplying 5 in the numerator and 5 in the denominator.
Ma'am, is there any other way we can do this?
This is the expected way and this is the formal way. So it is expected from you also to do it in this way only. Okay?
Okay, ma'am.
Ma'am,
Yes.
Actually, I joined late. Can you just tell me what all have you done till now?
Yes, yes, sure. This was the question. The decimal
Okay.
expansion of the rational number 43 upon 2 raised to the power 4, 5 raised to the power 3 will terminate after how many places of decimal? Okay.
Okay, ma'am.
So what we did was, in the denominator, we have to see the power of 10 to identify the number of places of decimal. So what we did was, there were four twos, but only three fives. So what I did was I multiplied 5 in the numerator and 5 in the denominator, and I got 2 and 5 upon 2 raised to the power 4 into 5 raised to the power 4. So now 2 into 5 was 10. So I finally got 2 and 5 upon 10 raised to the power 4. So as the power of 10 is 4, that is why it will terminate after 4 decimal places.
Okay, ma'am. Thank you.
Ma'am, why is it so?
Yes.
Ma'am, that the power, like whatever the power of 10 is, it will dominate after 4 digits like that.
Okay. So why is it so? Suppose if you have a number 2, okay, if I divide it by 10, then how can I write it in decimal form?
0.2.
0.2. So how many places after decimal?
1.
1. Okay, great. So now if I write 2 by 100, then what will I get?
0.02.
0.02. So now how many places after decimal?
2. Okay, ma'am, got it.
Now got it? Great. Now, should we move on to the next question? Okay, one doubt was there. Rishikesh asked, can we multiply by 1 by 2? No, we cannot multiply by 1 by 2. It will be easier to multiply by 5 in the numerator and denominator. Then the number in the numerator is 215, not in decimal. If you multiply by 1 by 2, then in numerator also we'll get in decimal form, and then it will become so confusing. That is why we multiplied by 5 in numerator and denominator. So now should we move on to the next question? This is the next question. Find the largest number that will divide 398, 436 and 542, leaving remainders 7, 11 and 15 respectively. Okay, you have 2 minutes to solve this question. Okay, so you want him. The largest number that will divide. So Okay. It is asked in the question the largest number that will divide. Divide is factor. Largest is highest. We need to find the highest common factor. But the numbers given are 398, 436 and 542 and they're leaving the remainder 7, 11 and 15. So this is a trick in the question. Anyways, we'll discuss that. Okay, so now I think we should move on to the solution part. And then match the answer. If you got it correct, then great. Otherwise also, no problem, okay? So we have to find the largest number that will divide 398, 436 and 542, leaving remainders 7, 11 and 15 respectively. So whatever the number is, when it will divide 398, it will leave the remainder 7, right? So if I subtract 7 from here, the number will divide it perfectly. It will be a factor of this number. Same way, the number on dividing by, if 436 is divided by that number, it leaves the remainder 11. But if I deduct 11 from this 436, then that number will be a factor. Again, 542 minus 15. So what we get here is 391, here 425, and what is 542 minus 15? 527. So the number is the factor of all these three numbers, right? Now we have to find the largest number. So it is obvious that we have to find here highest common factor. Highest common factor of these resulting numbers, which are 391, 425 and 527. So who will tell me how to find the highest common factor?
Ma'am,
Yes.
ma'am, the largest factor of the largest power of each factor.
The largest power of each factor.
Yeah, we have to multiply.
So can you tell me the
Prime factorization.
okay prime factorization? So 391 का prime factorization क्या होगा? Who will tell me?
17 into 23.
Okay. Yes. 425 के का प्राइम फैक्टराइजेशन कौन बताएगा मुझे?
5 into 5 into 19.
17.
5 into
5 into 5 into 17.
5 into 5 into 17. Great. And 527 का प्राइम फैक्टराइजेशन क्या है?
17 into 31.
Yes. So now what is the highest common factor here?
17.
Yes, 17 is the highest common factor.
Ma'am, could you scroll this screen a little bit up?
Yes, yes. Any doubts, anyone? The answer is here 17. Everybody understood this question and
Yes, ma'am.
solution? So should we move on to the next question now? Okay. So the next question is HCF and LCM of two numbers is 9 and 459 respectively. If one of the numbers is 27, then you have to find the other number. So you have 2 minutes to solve this question and let me know the answer. Yes, Soumil, it is correct. Yes, Arushi, great. Yes, Rishikesh. Okay. So now let's discuss the solution of this.
Ma'am, can you wait for a minute?
Acha, theek hai. We'll wait for a minute. Yes, correct answer, Kuldeep. So now should we discuss the solution?
Yes, ma'am.
Okay. So what do we know here in this question? We know that HCF is given as 9, LCM is 459, and one of the numbers is numbers is 27. And we know that HCF into LCM equals to product of the two numbers. Okay. So now HCF is given as 9, LCM is 459. Product of the numbers, so one number is given 27, but the other number is not given, so I'm assuming it to be A.
X. Ma'am, X can we take
Okay,
27?
X. Let's take X here. No problem. So now X equals to 9 into 459 by 27. So 9133153. So the correct answer here is 153, and the question was to find the other number. So the other number is 153. Everybody understood the solution?
Yes, ma'am.
Okay. So should we move on to the next question? Any doubts, anyone?
No, ma'am.
Okay. So this is the next question. You have to find the HCF of 865 and 255 using Euclid's division lemma.
Ma'am, Euclid's division lemma is omitted from
Yes,
our
ma'am.
course.
Acha, it's omitted. Okay.
Yes, ma'am.
Then find the HCF using prime factorization method. Is that fine?
Yes, ma'am.
Yes, ma'am.
Okay. So in place of Euclid's division lemma, yes, Arushri, it is correct. Yes, Kuldeep. So now let's discuss the solution. Yes, Somili. So now let's discuss the solution.
Ma'am, is my answer correct?
Yes, yes, it is correct. Now, would you like to tell me the prime factors of 255?
5 into 3 into 13.
5 into 3 into 13. And 865?
Ma'am, for 255, it's 5 into 3 into
3 into
17.
17.
Yes, ma'am. Sorry, ma'am.
Okay, no problem. So it is 5 into 3 into 17. And for 865, it is
5 into 173.
173. So what is the highest common factor
From
here?
5.
5.
Yes.
Yes. So the highest common factor HCF of 865 and 255 is 5. Great. So this was an easy question. So let's move on to the next question then. This is the question. You have to find the prime factorization of the denominator of rational number expressed as 6.12 bar in simplest form. This is a non-terminating decimal. You have to find the prime factorization of the denominator of rational number. Who got the answer? Yes. So what is the question asked, Kuldeep?
Ma'am, we have to write it. We have to find the prime factorization of the denominator and
Yep.
of the rational number expressed as 6.1.
Okay. So what is the prime factorization of the denominator in your answer?
Okay, ma'am. So I had not completed. I just did.
Yes, yes. Yes, Arushi, it is correct. No, Somali, just check it once again. Yes, Kuldeep, now it is perfect. So I think we should move on to the solution part now. Okay. So we have to find the prime factorization of the denominator of rational number. Okay. So you have to find the prime factorization of the denominator you got. So just complete it. One more step is left in your answer. Okay, so we are discussing the solution now. First, we have to convert this decimal form into okay. So what I'll do first is I'll just uh, assume that x is equal to 6.12 bar. Assume means I let x is equal to 6.12 bar. And now,
Ma'am, is my answer correct?
yes, it is 3 into 11. It is correct. Okay.
Thank you.
Okay. So x is equal to 6.12 bar. Now what I'll do is I'll multiply this equation by 100. I'll multiply 100 at left hand side and I'll multiply 100 by right hand side. So 100 into x. What will we get if we multiply 100 to 6.12 bar?
612.12.
Yes. So it is 612.12 bar. Now what I can do is, if I denote this by equation 1 and if this is equation 2, if I perform subtraction on equation 2 and 1 and if I subtract equation 1 from equation 2, 1 from equation 2, what do we get? 100x minus x equal to 612.12 bar minus 6.12 bar. So we get 99x equal to 606. Is it okay? So now x equal to 606 by 99. So what I can do here is,
Ma'am, if we don't reduce this, is that fine? If we write the prime factors of 99, is that fine?
no, you have to reduce it first and then you have to write the prime factorization.
Okay, ma'am.
Okay. 303, sorry, it is 3 into 202 and 3 into 33. So what we got here is 202 by 33. So the denominator is 33. So prime factorization of denominator will be is 3 into 11. Any doubts, anyone? Or should we move on to the next question?
No doubt, ma'am.
Okay. So let's move on to the next question then.
मैम आप एक बार लाइक थोड़ा सा ऊपर कर दोगे 1 सेकंड
हाँ हाँ हाँ
प्लीज चेक नहीं मैम थोड़ा सा नीचे लाइक मिडिल पार्ट जस्ट अ सेकंड
okay.
yes ma'am done thank you ma'am
Okay. So now this is the next question. You have to find the composite number x and you have to complete the following factor tree.
Ma'am, what is this 2012?
This question appeared in 2014 paper.
Okay, ma'am.
so ma'am like it is very easy if you see but ma'am then like the method which is told to us in the book we have to use that only
Yes, it is easy. You have to just when you reach to the answer, you have to elaborate your answer. Like you have to write the steps involved.
And ma'am, I think X and Y are same.
X and Y are not same. They can't be same.
Yeah, got it.
And for X, we will multiply it.
Yeah.
Yes, Rishikesh, it is correct. Arushi, it is correct. Kuldeep, your answer is correct.
Ma'am, I have sent you the answer.
Okay, okay. So it is, the answer for X is 585. Yes. And why it is 585?
Ma'am, we should multiply 195 by 3 to get X, and for Y, we should multiply
But
13.
ma'am, for this, how do we write these steps?
Ma'am,
Because
like what
we
is the
can
correct
directly
way CBSE
multiply.
would say? Ma'am,
Okay.
what is the correct way CBSE would prefer and give us marks?
Yes. वैसे this will be given in a very short answer, or if you have that
MC?
1 mark questions, then. So if it is given in 1 mark question, then you can directly write the answer that X is 585. Okay. But if it is given in 2 marks, then no need to worry. You will just write here that Y in terms of its prime factors. So it is 5 into 13. What it is? 65. Then you will mention 195 also, okay? 3 into Y, just to check it. So 3 into 65. It is correct. It is coming 195. It was given. So fine. Now, if I write X in terms of its, and what I can do here is one more thing. I can express 195 in terms of 3 into 5 into 13. Okay.
Ma'am, like, is this necessary to do? Like,
Yes, if it is of 2 marks, it depends on the mark distribution. If it is of 2 marks, then you'll write like this. But if it is of 1 mark, then you'll directly give the answer and you can move on to the next question. Okay.
yes.
Ma'am, how is 195 3 into 5 into 13?
How is 195 3 into 5 into 13? Because
Okay,
190.
ma'am, got it, ma'am.
Okay, got it. Because its prime factors will be this, this, and this. Then we have to write X. So X is 3 into 195. So you got it as 585. And you can also express it, if it is of more marks, then you can express it as 3 into 3 into 5 into 13. Okay. So in prime factor tree, it is 3 into 3 into 5 into 13. So I hope it is clear. So let's move on to the next question then. So just try this question, as this question is of proving. So try it in your copies. You have 2 minutes to try and then we'll discuss the solution here. So you have to prove that 2 plus 3.
Can you show the previous question for a second?
Yes, yes, sure. So 1 more minute and then we'll discuss the solution. Okay.
Done, ma'am.
Okay. So what is the first step here? What will I do first in this question?
Ma'am, we'll assume that 2 plus 3 root 5 is rational.
Yes, perfect. So we'll assume that 2 plus 3 root 5 is a rational number. Okay, and what is a rational number?
A number which can be expressed.
Number which can be expressed as P upon Q, where Q is not 0.
Okay, so what I'll do here is I'll write it as P upon Q, where Q is not equal to 0. Now what I'll do is I'll subtract -2 from both sides. So what I get is P by Q minus 2. And then I'll divide 3 on both sides. So what I get is root 5 equals to P by 3Q minus 2 by 3. Now what is the problem here?
Ma'am, LCM is not same.
LCM is not same. Okay, so I'll write it P minus 2Q by 3Q. Now is it fine?
Ma'am, a rational number cannot be equal to an irrational number and root 5 is irrational.
Yes. So it is a contradiction. This thing is a contradiction. We know that root 5 is an irrational number. So it cannot be equals to a rational number. So this is a contradiction. Contradiction. So if it is a contradiction, then what we assumed was wrong. So our assumption that what was the number 2 plus 3 root 5 is a rational number is wrong. Hence 2 plus 3 root 5 is an irrational number. So everybody understood the solution?
Yes, ma'am.
Okay. So we should move on to the next question.
Ma'am,
then.
can you show it again?
Yes, yes. Tell me when you are done with the solution part.
Done, ma'am.
Okay.
1 minute, ma'am. 1 minute.
Is it done?
Yes, ma'am.
No, can you show the last line?
Ma'am, can you explain this step, ma'am? Root 5 is equal to P upon 3Q and minus 2 upon 3, that step.
Ma'am, थोड़ा और ऊपर कर दो, please.
I'm explaining it. So first what we did was we assumed that 2 plus 3 root 5 is a rational number. Okay, so if 2 plus 3 root 5 is a rational number, then what is a rational number? What do we know about rational number?
Ma'am, anything that can be written in the form of P upon Q where Q is not equal to 0.
Yes. So now what I did was 3 root 5, I subtracted 2 from both sides. Okay, so this side becomes 3 root 5 and this becomes P by Q minus 2. Okay, and then I divided both sides by 3. So then what I get is root 5 equals to P by 3Q minus
Oh, okay,
2 by
ma'am.
3.
So, ma'am, should we mention that step there?
Yes, it's better to mention every step to fetch full marks. But like in this is a very basic calculation that we are dividing 3 on both sides, we are subtracting 2 from both sides. So I think you can omit that as it is not the main step in this chapter. So is it clear now, this step?
Yes, ma'am.
Yes. So now let's move on to the next question. You have to explain.
Done, ma'am.
Done. Okay. So why is it a composite number?
As it has more than two prime factors,
Yes.
it is divisible by those factors. Hence, it's a component. And one prime, there are only two factors.
Okay.
When we take common in it, we will.
It can be expressed as product of primes.
Yes, ma'am.
Yes. It has factors other than itself and 1. That is why it is a composite number. So let's solve it. So here it is given 17 into 5 into 11 into 3 into 2 plus 2 into 11. So 2 into 11 I can take out common. So 2 into 11 inside what is left is 17 into 5 into 3 plus 1. So it is 2 into 11 into
17 into 15.
17 into 15. And it
Oh, ma'am,
is,
directly can we just multiply?
yes, 255 plus 1. So it is 2 into 11
Plus 256.
256. So up yahin tak it is clear that it has more than two factors, right? 2 into 11 and all the factors of 256. So it is definitely a composite number.
Ma'am, is this class of 1 hour?
Yes, it is. This class is of 1 hour. Okay. So I hope this question and its solution is clear to all of you. So should we move on to the next question?
Yes, ma'am.
Yes, ma'am.
Okay. So can this number 4 raised to the power n can end with the digit 0 for any natural number
No,
n?
ma'am.
Why no?
Because, ma'am, we don't have 2 and 5 as its factor of
Yes.
2.
If we factorize it, then it is 4 can be written as 2 square. So this becomes 2 raised to the power 2n. So the only prime factor here is what? 2. There is no 5 in the prime factorization of number 4 raised to the power n. Hence, it cannot end with digit 0 for any natural number. So it is clear to all of you?
Yes, ma'am.
Okay, so let's move on to the next question then. 3 bells toll at intervals of 9, 12, 15 minutes respectively. If they start tolling together, after what time will they next toll together? You have 2 minutes to solve this question.
Ma'am, these types of questions come in both?
Yes, it comes. These type of questions also come in board.
Ma'am, because these types of questions are neither in NCRT nor in Exemplar or RD Sharma.
Okay, but try it.
Ma'am, was my answer correct?
Um, it's not 3 minutes, but Somili is correct. Arushi unit you have to check. Um, no. Okay. I think we should discuss the solution. Yes,
Ma'am,
Somili.
is my answer correct?
May I know your name?
2 milli.
Huh?
2 milli.
Yes, Somili, it is correct. Yes, Arushi, now it is correct. So I think you all have tried the question. So let's discuss it now. Okay. So the questions like these have appeared in examinations, in board examination. That is why we are taking it here. Okay. So it's better if you prepare the questions like these. Word problem based questions are asked, and many a times it has been asked in a value based question. Okay, so now let's discuss this question. So it is given that 3 bells toll at intervals of 9, 12, 15 minutes respectively. Okay, so if I see the first bell, uh, it tolls at 9 minutes, then second after 18 minutes, okay, and third it will, yes, Sovit, it is 180 minutes. So on. For the second bell, it will first toll after 12 minutes, then 24 minutes, and then 36 minutes, and so on. And likewise, for the third bell, it is 15 minutes, it is 30 minutes, it is 45 minutes, and so on. What
Ma'am,
we
here we can simply find the LCM, right?
yes, you can simply find the LCM, but some people some people find it difficult to uh, determine that whether we have to find LCM or we have to find HCF. That is why I'm explaining these steps. Okay.
Yes, ma'am.
Hmm.
But ma'am, we have to take LCM because HCF is like the bell will ring after every interval.
Mm. Yes.
Ma'am, can we just start the answer by saying that we'll find the LCM?
Yes, you can start with that. We
I
can
get
find.
confused in these questions whether we have to find the LCM or HCM.
Ma'am, exactly why do we have to find the LCM?
Yes, that is what I am telling you. Okay. So इधर तक समझ आया सबको कि these are the intervals where bells will toll. So first bell will toll at 9 minutes, then after 18 minutes, then second toll will be 18 minutes, then third toll will be 27 minutes. Right? इतना clear हुआ सबको?
Yes, ma'am.
हाँ. And for second bell, it will toll first after 12 minutes, then 24 minutes, then 36 minutes, 15, 30, 45 for third bell. Right? So what are these? These are multiples. Okay, and we have to find when will these three bells toll together. So we have to find their common multiple. Okay. And then the next thing is the next toll together. So there will be many common multiples. There can be many common multiples, but we have to find the lowest common multiple for them to toll together next, because it is asked just after. It is asked will they next toll together. That is why we have to find lowest common multiple. So this is the reason why we thought of finding LCM. Now is it clear?
Yes, ma'am.
हाँ कि कहाँ पर we have to find LCM and कहाँ पे we have to find HCF. In this case, multiples were involved and we had to find the common multiple. But in question it was asked next. That is why we had to find lowest common multiple, and that is LCM.
So, ma'am, it would be 3.
3 LCM is 3 hours. LCM of 9, 12, 15 is what? 9 is 3 into 3. 12 is 3 into 2 square. 15 is 3 into 5. So the LCM is 3 square into 2 square
Ma'am, into 5.
5. So what it is?
180.
Yes, it is 180 minutes.
Ma'am, 3 hours.
Yes, so 180 minutes is 3 hours. So now let's quickly take this question. This is of HCF, okay? I think we should discuss the solution here, okay? Because this is of HCF, that one was of LCM. So this difference between LCM and HCF will be clear. So two tankers contain 850 liters and 680 liters of petrol. We have to find the maximum capacity of a container which can measure the petrol of each tanker in the exact number of times. Okay, so we have to take out the petrol from the first tanker or second tanker. So what it involves is factor. So we have to find the highest common factor. Like here, see.
Ma'am, I've sent the answer.
Okay. Okay, so let's calculate it and then so we will get to know that your answer is correct or not. Okay. So is it clear to everybody that why we have to take HCF common factor?
Ma'am, I'm confused.
Yes, ma'am.
Okay, who is confused?
Ma'am, it's me, Kuldeep.
Okay, okay. So here, Kuldeep, we have to find the maximum capacity of a container which can measure the petrol of each tanker in the exact number of times. So what we have to do is we have to find some number, okay, some number x which will measure it in the exact number of times. So what will come is a positive integer will come. Okay. So
Yes.
what is x here? X here is a factor of 850, right? It is not a multiple of 850. X is what? X is a factor of 850. And likewise, same condition. We have to find some number so that it exactly divides 680 liters of petrol. So here also positive integer comes. So this is also a factor. Now it is asked, but common factor can be 1 also. We can take 1 liter of petrol, we can measure, we can have a container of 1 liter. But no, they have asked the maximum capacity of a container, maximum possible factor, which can measure the petrol of each tanker in the exact number of times. So we have to find the highest common factor between 850 and 680. This is the reason why we are finding HCF here. Now is it clear, Kuldeep?
Yes, ma'am. Now I got it.
Okay. So what is the HCF of 850 and 680? Who will tell me?
Ma'am, is it 10?
Is it 10? Okay. So let's calculate it and then we'll get to know. Okay.
Ma'am, I guess it's 170.
Okay. So who will tell me the prime factorization of 850?
Ma'am, it's 2 into
2
5
into
into 5 into
17
17.
2 into 17 into
Into 5 into 5.
5 into 5.
great. And what are the factors of 680?
2 into 2 into 2 into 5 into 17.
2 into 2 into 2 into 5 into
17.
17. So what is the highest common factor here? This.
170.
Okay. So 2 is here, 5 is here. So the HCF of 850 and 680 is 170. So now what was asked in the question? The maximum capacity of a container which can measure the petrol the maximum capacity of a container which can measure the petrol of each tanker in exact number of times is 170 liters. So now I hope this confusion between where to find LCM and where to find HCF is resolved, right?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. So this was all for today's class. See you all in the next session. Okay.
Bye,
Thank you,
ma'am.
ma'am.
Thank you, ma'am.
Thank you. Bye bye.
Thank you.
Thank you.
Thank you, ma'am.